Hello, welcome back. Continuing our series on graphing rational functions, we are up to step 4, which is to find the vertical asymptotes. So let's start by a quick reminder of what we've done so far. Okay, so if you haven't watched the videos for these already, take a peek, but we fully factored the numerator and denominator of our function. We found the x-intercepts, the y-intercepts, and we remembered to identify wholes. We took a look at multiplicity to see what there was to learn about the behavior around the x-intercepts from our multiplicity. And today, we're going to find the vertical asymptotes based on the zeros of our denominator, and then we're going to graph those vertical asymptotes using a dashed line. Okay, so first let's talk for a second about what an asymptote is. An asymptote is a point in your domain that you approach but never achieve. And then quick reminder, domain is everything your x is allowed to be. So vertical asymptotes in functions visually look like a function approaching a certain point, but then going off to positive or down to negative infinity because they never actually achieve that point. They get infinitely close, but they never hit it. And what makes vertical asymptotes are things that are not included in the domain, and namely in this case, it's things that would give us a 0 in the denominator of our function, because as we know, things divided by 0 are undefined. They don't exist. All right, let's take a look at this on our 3 examples. So let's take a look at example number 1. So here's our function, and then here's the factored version of our function. And in step number 2, we found the x-intercepts based on where our numerator would go to 0. For our asymptotes, we want to do the same thing with our denominator. So I'm going to call this step 4, and step 3 was looking at multiplicity, and we don't have any multiplicity. These are each raised to the 1. So we're going to take each of the factors of our denominator and set those equal to 0. And then we're going to use our inverse operations. If we have x minus 4, we want to add 4 to both sides. So that tells us we have an asymptote at the line x equals 4. And again, here, opposite operation. So we would want to subtract 4 from both sides. And that tells us we also have an asymptote at the line x equals negative 4. So asymptotes are lines. So let's go ahead and take a look at our graphing paper. So here we are, and we've graphed our x-intercept and we've graphed our y-intercept. And now we have an asymptote at the line x equals 4. So 1, 2, 3, 4, and we are going to make a dotted line through that point 4. And it always throws me that x equals is a vertical line, but that's because it means for any value of y, our x always equals 4. And then same thing over here, 1, 2, 3, 4, we're going to make an asymptote through negative 4. And then as we figure out our graph, we're going to see that it's going to approach but never hit our asymptote. And then on the other side, it's going to approach but never hit our asymptote. So that's for later on, but that's how we do the asymptotes. All right, let's do it again. Here's function number 2. We found our zeros by factoring, and now here we are at step 4, and we're going to find our asymptotes by taking the factors of our denominator and setting them equal to 0. We only have one, x equals 0. So we go on over to our graph. And the line x equals 0 is actually the y-axis. And we predicted this earlier. We said the y-axis was going to be an asymptote. All right, and finally, let's do it with our last function. We found our zeros from the top. Now we're going to find our asymptotes from the denominator. X minus 1 equals 0. X plus 2 equals 0. That means x equals 1. and x equals -2 are our asymptotes. Oh, except, sorry, I did this last time too, except this is not an asymptote. Even though we have x minus 1 in the denominator, because we also have it in the numerator, that classifies this as a whole and not an asymptote. So what that looks like on our picture, we've already got our whole there. So instead of an asymptote, we have a whole, and then over at x minus 2 is where we have our asymptote. All right, so that right there is how you find your asymptotes. You look at the factors of your denominator, you set them equal to 0 and solve, and you draw a dotted line through that point. All right, practice that. Go back and review videos 1 through 4 at this point, and then stay tuned for video 5, where we're going to talk about our horizontal asymptotes. All right, keep working hard, and as always, keep on mathin'.